So here's the question. A spherical balloon is being inflated so that its diameter is increasing at a rate of 2 centimeters per minute. So right here, I know that the diameter is increasing. So let's call this diameter, dt is 2. And how quickly is the volume increasing? So we're looking for dv dt when the diameter is 10. That's what I want. So I need to find a relation between the diameter and the volume. Okay, so just a reminder, the volume of a sphere is 4/3 pi r cubed. Okay, and of course the radius is equal to the diameter divided by 2. Okay, so basically we have V, volume is 4/3 pi times diameter over 2, which is radius, cubed. That means that the volume is 4/3 pi times d cubed over 8. And therefore V will be pi over 6 times d cubed. Okay, now I have my relation between V and D, so I do the derivative of both sides with respect to t. So dv dt pi over 6 3d2 times d diameter dt. And that's it. All the rest, I have the information. Yes?
Isn't it pi by 2?
Oh, yeah, sorry. Sorry, it's over 2. I said 2. No, it's 6. Why 2? Why 2?
Oh, no, never mind. You put the 3d squared. Never mind. I thought you didn't. Sorry.
Yeah. So dv dt is what I'm looking for. Okay, so this is what I'm looking for. Then the diameter is given to me as being 10, right, when d equals 10. And the diameter increases at a rate of 2. Okay, and so I could now solve for dv dt. Is pi over 6 times 3 times 2, so this cancels, so I get 100 pi. Okay, centimeters cubed per minute, and that's my answer. Perfect. Okay, any questions? So number 2, here's a situation. A person is 6 feet tall, is walking away from a lamppost at a rate of 40 feet per minute. Okay, so I like to do a little representation here. Okay, so he's walking away from the lamppost at a rate of 40, and when the person is 10 feet away from the lamppost. So he's 10 feet away. Okay, so let's say he's here, and his height, he's 6 feet tall. Okay, so this is 10. This is 6 given to us. Okay, or actually, this is x. Okay, because he's moving away, so this changes. And there's a shadow. Okay, so this is the lamp. And he's going like this. Okay, and this is the shadow, y. Okay, so let's see what's given to me now. 6 feet tall, so this is constant. Okay, this doesn't change. He doesn't change the height, the guy. Okay, he's walking away at 40 feet per minute. So this is my dx dt. So this given to me, dx dt is equal to 40. Okay, so his shadow is 20 long. So when this is 10, this is 20, that's given to me. Find the rate at which the length of the shadow is increasing when he is 30 feet from the lamppost. So we're looking for dy dt when x is 30. That's what I'm looking for. Okay, so I need a relation between x and y. Okay, so they give me one information. The information they give me is that when he is 10, when this is 10, if x is 10, it means that y is 20. That's given to me. His shadow is 20. Okay, so basically, I have a situation like this. $26 and sorry. I'll draw the two big triangles again. It's better. Oops, sorry. So this is like this. $90 degrees common angle. So this small triangle, which has a dimension 6y, okay, is similar to the big triangle here, which has dimension, this is x. Okay, so I know that when this is 10, this is 20. So the ratio will always be maintained between y and x plus y. Okay, so basically here I have that y divided by x plus y has to equal to 20 over 30. This is given to me. This I know. Okay, therefore 3y is equal to 2 times x plus y, and so y is always equal to 2x. Oops, let me move up a bit, sorry. Okay, so y is equal to 2x. And I could now find the relation between the two derivatives. Okay, so dy dt is equal to 2 dx dt. Okay, and therefore this is equal to 2 times dx dt, which is 40. And so my answer will be 80, I guess, feet per minute. Okay, that's my answer. Any questions? Okay, no question. Let me pose the next one. Still need to
Wait, sir,
copy?
can you keep it, please?
Yeah, let me know when you're done. Okay, so let's continue. Next one, number 3. Number 3 is right here. Okay, so I prepared 5 questions. So this is number 3. If you could do all these 5s, you should be fine. Okay, and I'm going to post some old tests, and you'll see that these are supposed to be harder, and you'll see that you get it. You'll be fine. So here is number 3. Try it on your own. So here we go. 2 cars start at the same place. Okay, one travels north at 30 miles per hour. And the other one leaves an hour later and travels west at 40 miles per hour. But it starts 1 hour later. Okay, so after 1 hour, right, the car that's heading north has already traveled 30 miles. Okay, and then he's traveling here the rest, a certain distance x he's traveling. Well, this guy here, okay, so I'm going to go like this to make it a bit more realistic. He's traveling at a certain speed y. Do you understand the picture here? Okay, this 30 comes because he starts 1 hour later. And so when he starts, he's already here. So go, they're advancing like this. Okay, and west, and the other one's north, perfect. And what's given to me here? dx dt is 30. That's given to me. And dy dt is 40. Okay, I'm looking for the rate at which this distance is changing. Okay, so I'm going to call this z. Okay, and we're looking for dz dt when at the instant the second start has been traveling for 1 hour. So when is that? When this car y here has been traveling for 1 hour. So basically, y is, what distance is he here? What's y?
40.
40,
And what's x?
60.
No, x is 30.
Yeah, but
This distance, you're right, it's 60, but x is still 30.
oh, you're right. Oh.
Okay, 1 hour later, he's 30. Okay, so that's what I'm looking for. This is my problem. It's a related rate, so I need to find a relation between x, y, and z. So obviously, I'm going to use Pythagoras theorem. X2, sorry, made a mistake. So 30 plus x squared plus y squared is equal to z squared. That's what I have. And so I'm going to do the derivative. 2 times 30 plus x times the derivative of the inside dx dt plus 2y dy dt equals 2z dz dt. Is that okay? All right, let's get rid of the 2's just to make things a bit cleaner. So x plus 30 times dx dt plus y dy dt is equal to z dz dt. Okay, so let's see what's given to me here. So dx dt, I know it's 30. dy dt, I know it's 40. dz dt is what I'm looking for. Okay, x is 30, it's given. Y is 40, it's given. So the only thing I need now is z. So what's the value of z when I'm taking the picture? So 60, 40, and so I can find what that is. Okay, so I'm going to use Pythagoras. So 60 squared plus 40 squared square root. So 72.11. That's my z here. That's my z here. And now I have all the information. I could find what dz dt is. Okay, so basically 60 times 30 plus 40 times 40 equals 72.11 times dz dt. And I hope I'm getting this right. I did not practice before, so dz dt will be what? So this is 1800 plus 6, so 1800 plus 1600 divided by 72.11. I get 47.15, perfect. The answer is right. Any questions? So here's another one. Right here. Okay, so the radius of a cylinder is increasing at a rate of 1 meter per hour. So we're talking about a cylinder here, so let me draw it. Okay, so I have the radius r and the height h. Everything is moving here. Okay, the radius is moving, the height is moving. So what's given to me? The radius is increasing, so that's a rate of increase. So dr dt is increasing at 1. And the height is decreasing at 4, so it's -4. Okay, it's decreasing, so every hour it loses 4 meters. We're looking for the rate of change of the volume. So we're looking for dv dt is what? At that instance where what? Where the base is radius is 5, so r is 5, and the height is 8. Okay, so this is pretty easy. It's much easier on the other one. So we need a corresponding relation that joins V, H, and R. So what's the volume of the cylinder? So area of base times height. Okay, and so we derive both sides with respect to t. So dv dt is equal to, so be careful now, we have a product rule. So the derivative of pi r squared, so it's 2 pi r dr dt times h plus pi r squared times dh dt. Don't forget here, okay, to use the product rule. So I'll write here. And I think everything else is given, I think. So this is, we're looking for radius. They told me that it's 5. dr dt, they tell me that it's 1. Height, they tell me that it's 8. This is 5. And the h dt is -4. And that's it. Okay, so 8, 40, 80 pi minus 20, so 25, 100 pi. So did I do something wrong? I guess so.
I got the same answer.
As
Minus
me?
20. Yeah, minus 20.
I got the same thing too.
I got -20?
Yeah.
Okay, so
minus
maybe
20 pi.
I copied the answer wrong from somewhere. Okay, so -20 pi, perfect. -20 pi meter cubed per hour. Okay, so this is wrong. Okay, so maybe when I copied the answer, I put a -1 for nothing here. So it's -20 meter cubed, -20 pi. I forgot the pi actually. Okay, -20 pi meter cubed per hour. Okay, any questions? Oops. So you can see. Okay, so the trick, the added difficulty in this question was that we had to use a product rule. Okay, are there any questions?